Well, we've got another fun lesson on a little more review of exponents, and then we'll introduce some rational equations tonight. So let's first start with the review of our exponent properties thus far. So you might want to take a moment, copy them down. We've talked about quite a few of them. And then we'll go back and we'll talk each one out. All right, letter A. X to the A times x to the B. Notice when the bases are the same and we multiply, what do we do with the exponents? Hopefully your gut has already said add. So this would be x to the A plus B. B, x to the A raised to the B. Okay, notice we have that power to a power, and this was the product property. So this is just x to the A times B. C is raising a quantity to a power. And remember, that just tells us everybody in here gets raised to that power. So this is just x to the A times y to the A. D, 1 over x to the A. Well, that's our rule. If something went to the bottom, that means the exponent was negative. So this is really x to the negative A. E, x to the A divided by x to the B. Again, as long as the bases are the same, you keep the base and you subtract the exponents, A minus B. F, similar to that other property, everybody inside gets raised to that power, even if it's a fraction. So that's x to the A over y to the A. G, anybody to the 0 power is 1. H, this is that unit fraction property. So we said this is the nth root of x to the first. Remember, we described roots as being in the bottom of a flower, a plant, a tree, etc. So that number on the bottom always describes the root. And finally, I, this again is the nth root of x to the m power. Now remember, they can rewrite this another way as the nth root of x, and they could put that m power all outside. So just be familiar with both. All right, so these directions say write each as a radical and then write as a single integer. So what property am I looking at? Well, when I multiply things with common bases, remember you keep the base, so this is 7, and you add the exponents. 1/2 plus 1/2, hopefully you can add off to the side, a half plus a half is equal to 1. So this is just 7 to the first. Now notice it did say write as a radical, which I totally skipped over, so let's go back and rewrite as a radical. The number on the bottom describes the root, so this is the square root of 7 to the first times the square root of 7, and the square root of 7 times the square root of 7 is the square root of 49, which we know is just 7. So we solve this two different ways, one with exponent rules, and then one by rewriting as radicals. B, 3 to the 1/3 times 3 to the 1/3 times 3 to the 1/3. Okay, so again, I could say this is the cubed root of 3 times the cubed root of 3 times the cubed root of 3. 3 times 3 is 9 times 3 is 27, so this is the cubed root of 27, which we know is just the number 3. Okay, I could also apply this to the exponent rules. I could say when I multiply, I keep the base at 3, and I'm going to add the exponents, 1/3, 1/3, 1/3, which makes 3/3, which is just 1. So again, two ways to derive this formula and get at the same answer. Okay, now C's a little trickier. Can you just multiply these and add the exponents? No. Good answer if you said no. That is not allowed, because remember, the bases have to be the same. So I can't do that here. The only thing I can do is rewrite as radicals. So I could say that the square root of 12 times the square root of 3, which is equal to the square root of 36, which is just 6. So again, I just want to be very clear that you cannot say 12 to the 1/2 times 3 to the 1/2 equals something to anybody. It doesn't work that way because the bases are not the same. So again, the only way I could do that was with my radical property. All right, D. This is that power to a power property. Whoops, lost my pen. I can take these two numbers and multiply. So I'm going to say this is 64 to the 1, 1 times 1, 3 times 2, 6. Okay, so now I'll rewrite that as the 6th root of 64. So what does that mean again? I need a number 6 times to multiply to 64. And I need the same number. So 1, 2, 3, 4, 5, 6. We'll just start at the beginning. 1 times 1 times 1 times 1 times 1 times 1 is obviously 1. That's not it. 2 times 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, 8, 16, 32, 64. Therefore, we have a winner of 2. Now, let me show you another method. Let me come back over here. 64 to the 1/3 to the 1/2. Could you evaluate 64 to the 1/3 first? Well, that's just the cubed root of 64, all raised to the 1/2. And we know the cubed root of 64 is 4, because 4 times 4 times 4. So I basically have 4 to the 1/2, which is really the square root of 4, which again is just 2. So 2 ways to get you the same thing. Okay, next let's practice evaluating these without a calculator. So our first job is to rewrite them. This is really the what root of who to the what power. Remember, roots are in the denominator, so the square root of 2 cubed. Now recall, order doesn't matter. If you want to take the square root first or the cube it first, it doesn't really matter. However, in this case, do you know the square root of 2? No, so you can't do it that way. I'm going to say this is equal to the square root of 2 cubed, which is 8. And the square root of 8 is really the square root of 4 times the square root of 2, so I'm going to say 2 radical 2. Okay, well now we'll make it a little uglier, of course. 8 over 64 raised to the negative 2/3. So I'm going to raise each power to that exponent. So I'm going to say this is 8 to the negative 2/3 divided by 64 to the negative 2/3. Okay, so remember that rule says everybody gets that power. Now, that negative exponent just turns it into a fraction, so this is 1 over 8 to the 2/3 divided by 1 over 64 to the 2/3. And I'll rewrite it as a root, 1 over the cubed root of 8 squared and 1 over the cubed root of 64 squared. Now it shouldn't be too bad. The cubed root of 8 is 2, and 2 squared is 4, so that's 1/4 all over. The cubed root of 64 is 4, 4 squared is 16, 1/4 over 1/16. So now this is just a complex fraction. Doesn't matter to me how you handle it. Again, I'm going to show you 2 ways. One way is to multiply by the common denominator. So out of a 4 and a 16 clears both, so I would use a 16. So that would get me a 4 over 1, which is just 4. Or the second way would be to say I could do 1/4, change division to multiplication, and flip the fraction. So I would get 16 over 4, which is just 4. So again, your method, complex fraction or keep, change, flip. All right, number 3. Again, everybody gets raised to that power. So 16 to the 1/2 all over y to the 1/2. And I'll rewrite, this is really the square root of 16 over the square root of y. I know the square root of 16 is 4 over the square root of y. And I think we're just going to leave it at that. Now again, if that's not the multiple choice, how could you rewrite this? Well, you can bring this up to the top just by making its exponent negative. So remember, that's really a 1/2. If I wanted to bring that back up, I could say this is 4y to the negative 1/2. Again, those are equivalent answers. All right, this last example here is a little sneaky. We call it make like a beaver and split. So here's the question. X squared plus 4x plus 2 divided by x, the radical x. The first thing I'm going to do is call this x to the 1/2. And now here's why we call it make like a beaver and split. When you're dividing by one term, you have to split this numerator up and divide each term separately by that. So watch how I just slowly rewrite it. X squared over x to the 1/2 plus 4x over x to the 1/2 plus 2 over x to the 1/2. Make like a beaver and split. Split each term up. Now, treat it as division. When you divide, what do you do with exponents? You subtract. 2 minus 1/2. Well, this is really 4 over 2 minus 1 over 2, so I get x to the 3/2. This is 1 minus 1/2. 1 minus 1/2 is 1/2. So plus 4x to the 1/2. Now here there's nothing to subtract, so we just bring it up to the top by making that exponent negative. And there you have it. Make like a beaver and split. Alright, so time for some new stuff. Rewrite and simplify the expression in two ways. One, in simplest radical form, and two, in simplest rational exponent form. Okay, now believe it or not, you've already done this before. Well, you've done half of it before, the radical form. And we're actually, I think, pretty good at it. So, it's just written a different way. All you have to recognize is that when you see raised to this 1/2 power, you can rewrite this as a what? Remember, that's the root. So let's go with method 1 of rewriting as a radical. You could really say this is radical, or square root, 48, x to the 5th, y to the 4th, z squared. Now, doesn't that look like a familiar problem? Like I said, we were pretty good at breaking these down. I'll go about it the long way. Maybe you can go quicker yourself, and if you can, go for it, but I'll write it out the long way. I have to break up 48, so I'm going to say that's 16 and 3. Because this is a square root, I can only use exponents of 2. So x squared, that's 2, 4, and there's going to be 1 left over to make 5. I'm going to do a y squared and a y squared. That would give me a total of 4. And then a z squared. Okay, because remember, I can only break it into exponents of 2. And then I just go and I go, okay, that's a 4. That's an x. That's an x. That's a y. And that's a y. And that's a z. And everybody else will be left in that radical, a 3 and an x. So I would say this is 4x squared, y squared, z, radical 3x. Okay, so now we're going to solve the same problem, but we're going to leave it in rational exponent form. So let's go back to this side, and I want you to recopy this problem down. And we're going to use one of our exponent rules that say anybody inside here gets raised to the 1/2 power. So I'm going to say this is 48 to the 1/2 times x to the 5th to the 1/2 times y to the 4th to the 1/2 times z squared to the 1/2. Okay, so it's a simple property. We've done it several times this week. And I'm just going to keep cleaning it up. 48 to the 1/2 is really the square root of 48. This becomes x to the multiply, 5 over 1. 5 times 1 is 5. 1 times 2 is 2, so that's 5/2. 4 over 1, so this becomes y to the 4 over 2, which is just 2. And then z, 2 times 1/2 is 1. Okay, so again, we're going to keep breaking it down. 48, just like we did before, is 16 and 3. That becomes a 4 and a radical 3. Okay, notice these don't have radicals anymore, the y squared and the z, so I'm just going to leave this as y squared and z to the 1st. Now here's where it gets a little exciting. This x to the 5/2. What we're going to do is we're going to say 5 divided by 2. 2 goes into 5 twice. That gives me 4 and a remainder of 1. That means you can take out 2 out of the 5. So out of x to the 5/2, you can pull out an x squared, and you're going to have 1 out of the 2 left over. So I'm going to say I'm going to be left with x to the 1/2. So let me say that again in case I lost you. This 5/2, I did 2 divided by 5. That's what it says, 5 divided by 2. So 2 goes into 5 twice. 2 times 2 is 4, remainder 1. So I can pull out x squared, because I have 2 of them, and I have 1 out of the half left over. So that's what this piece is here. So I can rewrite this as 4. I have an x squared, a y squared, a z. And remember, this is really a square root, and this is a square root, so I can say the square root of 3x. So you never know how the multiple choice might be written. They might leave it in this form here. They might leave it in this form, or they might put it back in this form. So let's try another similar one. Notice it's the same problem, but instead of being raised to the 1/2, it's now raised to the 1/3. So we're going to split it and do it two ways. We'll call this the one with the radical, and then rational exponent. All right, so let's start with the radical. Instead of calling it a square root, though, guys, be careful. You are now calling it a cubed root. So 48, x to the 5th, y to the 4th, z squared. So now I'm going to go about this the long way and really take my time and break down that cubed root of 48. So what two cubes multiply to 48? Well, let's think of our cubes. I have 1, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27, 4 times 4 times 4 is 64. Obviously 64 is too big. I need one of these numbers to go into 48. I'm going to say that's 6 times 8. Okay, so now when I break my cube root down here, remember, I need a perfect cube. So I could say that's the cube root of x cubed, but now how many are left over from the 5? I would say that's just x squared. Notice that totals up to 5. Y to the 4th, so I'm going to use the cube root of y cubed, and I'll be left with one of them left over. And z squared I can't break down because it's not big enough, so I'm just going to leave it as a cube root of z squared. Now, one thing people leave off on these, where we always feel like we're taking off points, is make sure if this is a cube root, guys, that you leave these cube roots on there. So now we'll just go through and ask ourselves, okay, who do we know? We know the cube root of 8 is the number 2. X cubed and x cubed match up, so out comes an x. Those match up, so out comes a y. And everybody else has to stay inside the cubed root. So now I have the cubed root. I'm going to leave in the 6, the x squared, the plain old y, and the z squared. And that leaves us in simplest radical form. Okay, let's do rational exponent form. So let's copy that same problem down. And use our exponent property. So again, that just says everybody gets raised to that 1/3. So 48 to the 1/3. See, that's going to be x to the 5/3, y to the 4/3, and z to the 2/3. Okay, so 48 again gets broken down the same way. We said that was, 8 and 6. Okay, now look at this. Let's see if we can do it in our head. 3 goes into 5 how many whole times? Well, that's a 1, so out comes an x. And you have how many left over? 2. So I'm going to say that's the cubed root of x squared. Okay, or you could leave it as x to the 2/3. Y to the 4/3. So 3 goes into 4 once, so you could pull out a y, and then you'll have y to the 1/3 left over. Z to the 2/3, well, 3 can't go into 2, so we're just going to leave it. So the 8 becomes a 2. We pulled out the x, we pulled out the y, and now notice they're all cubed roots, so I have the cubed root of 6 x squared y and z squared. And that should be the exact same answer that we had over here. Now, I just kind of want to go back, and again, you never know how they're going to ask this as a multiple choice, so I want to go back to this line here. So we could say this is the cubed root of 8 times the cubed root of 6, but they might just leave all those the way they are. So they might just say it's x to the 5/3, y to the 4/3, and z to the 2/3. So instead of breaking each of those down, again, I'm just showing you options. They might just say, okay, this is 2, and then they'll have 6 to the 1/3, x to the 5/3, y to the 4/3, and z to the 2/3. I just want to be clear that they're all equivalent. Some are just further simplified than others. All right, our next little piece is called solving rational exponent equations. So obviously you're solving an equation. That's a no-brainer. Solving equations. Here's my equal sign. It makes an equation. The only difference is our exponents are now rationals. And remember, rational comes from the 5-letter word in front, ratio. So the exponent is a fraction. So we'll jot a few notes down on to decide on how to solve. All right, so step number 1, we want to isolate the term with the exponent. Okay, so that's your first goal, is to isolate the term with the exponent. Now again, this just takes a lot of self-talk. You really have to say to yourself, who is the exponent sitting on? Is this 1/4 on the 4n or just the n? Okay, we practiced this earlier in the week. This 1/4 is only on the n, so wrap that in parentheses for yourself. They're not going to put that in there for you. That is only on the n. So your goal is to isolate that term with the exponent. So now I want you to box in this term here. That is who you are getting by yourself. If you have a nice colored pencil, that's a great time to do it. But that is the one term you need to get by itself. So you just kind of do inverse operations. If this says 4 times, to get rid of that 4, I'm just going to simply divide by 4. So I'm going to get 3 equals n to the 1/4. So now I have isolated the term that has the rational exponent. Now we're just going to use our exponent properties. So I can rewrite this as the 4th root of n to the 1st power. Okay, so now think about this. If I said, and you don't have to write this down, but just think about it. If I said the square root of x equals 6, what do you do to get rid of that square root? How do you get x by itself? Well, you would wrap this side up and this side up and square them, right? That kills that. So you do the same thing. If I have a 4th root, to get rid of a 4th root, I'm going to wrap each side up and I'm going to raise it to the 4th power. So the 4th root and 4th are gone, and I get n to the 1st equals 3 to the 4th, which is 3 times 3. 9 times 3 is 27, times 3 is 81. So there you have it, n equals 81. Now could you do a quick check to see if you're right? Of course, and you're crazy if you don't. Take that 81, store it into x, and then type this in. 4n to the 1/4. Did you get 12? If you did, you know you got the right answer. So we just finished a pretty basic one. Let's step it up and make it a little more exciting. Number 2, -3 plus 4x to the 7/5 equals 509. So again, that first step is the most important. Who is the 7/5 sitting on? The 4x or just the x? Hopefully your gut is saying just the x. So I kind of put that in a little box and say that's who I need to get by itself. That's my goal number 1, is to get that by itself. Okay, so what operation do you do first? Well, think about this. If I said 4x plus 2 equals 6, what do you do first? Do you divide by 4 or subtract 2 first? I know we all know the answer is subtract 2. So we're going to do the same thing here. You're always going to add and subtract first. So I'm going to add 3 to both sides. So I get 4x to the 7/5 equals 512. Okay, I'm going to keep this in a box for myself. My goal is to get this term by itself. And do the same thing. It's simple steps, and you'll get it right. Now divide both sides by 4. So I have x to the 7/5 equals, I'm going to do a little scratch work, 512 divided by 4. 4 goes into 5 once. It goes to 1 and 11. 4 goes in there twice. That's 8. That's a 32. So that's an 8. So that's a 128. Okay. So I'm going to carefully rewrite this side. Remember, roots are on the bottom. This is the 5th root of x to the 7th equals 128. Okay, so now you just say, if I have a 5th root, how do I get rid of it? Well, I wrap both sides up and I raise it to the 5th power. Those will cancel, and I'll get x to the 7th equals 128 to the 5th. Now, I don't have a calculator with me, so watch what I'm going to do. I'm not actually going to solve that side yet. I'm going to say, okay, how do I get x by itself? Well, I'm going to go back. You don't have to write this down, but just watch. If I have the basic equation, if I have x squared equals 9, what do I do to get x by itself? Well, I take the square root of it, right? So I'm going to take the 7th root of x to the 7th, and whatever I do to that side, I have to do to this side. So those zap out, and I get x equals the 7th root of 128 to the 5th. Now, believe it or not, I can do that in my head a lot easier than I can do 128 to the 5th. I don't know 128 to the 5th, but I do know the 7th root of 128. That just means I need a number 1, 2, 3, 4, 5, 6, 7 times to multiply to 128. And guys, I always start at the beginning. Obviously, 1's not it, because 1 times 1 times 1, etc. is 1. How about 2? 2 times 2 is 4, 8, 16, 32, 64, 128. So the 7th root of 128 is 2, and 2 to the 5th is 32. So x equals 32. And again, you can easily check this. Store it in, see if it checks. All right, 2 times the quantity b plus 12 to the 5/4 plus 8 equals 72. Again, step number 1 is the most important. Who is that exponent sitting on? Now notice they threw all these parentheses in here. So this exponent is actually on this whole sucker here. So box that in for yourself, and let's just slowly get it by itself. I'm going to add or subtract first, so subtract 8. What's it, 64. Divide both sides by 2. Okay, because again, my goal is to get this term by itself. So I have the quantity b plus 12 to the 5/4 equals 32. All right, I'm going to rewrite this as the 4th root. Now here's where you have to be real careful. It's that quantity b plus 12 all raised to the 5th. Don't lose those parentheses, otherwise we're going to screw this up big time. Remember, that whole inside gets raised to the 5th. All right, so to get rid of a 4th root, I just wrap it up and I raise both sides to the 4th power. Those cancel. So I get the quantity b plus 12 to the 5th equals, again, I don't know what 32 to the 4th is, so I'm just going to leave it there as 32 to the 4th. Okay, now if I have 5th power, I'm simply going to take the 5th root. Those cancel, and I get b plus 12. Now this one I can do in my head. The 5th root of 32 to the 4th. Again, I don't know the 32 to the 4th, but I do know the 5th root of 32. That just means a number 5 times that gets me 32. Hopefully you're pretty good at those by now, and that's just 2. And 2 to the 4th is 16. So b plus 12 equals 16. Subtract over my 12, and I get b equals 4. And again, a simple check, store it in your calculator, see what happens. Well, that does it for us. We'll look forward to any questions tomorrow. Have a great night.